Hello InfoPerson, this is Anton, and today we're going to discuss a category of exoplanets that should not even be possible according to some of the older definitions in textbooks and according to models in modern astronomy. Yet despite of this, we actually keep finding more and more of them, and they seem to be even more extreme than we initially thought. And here I'm talking about a type of planets that's now officially known as the puffy planets, or poofy planets, as I used to call them. But more intriguingly, there's even a kind of an extreme version of this, referred to as the super puff or super poof, more commonly known as the cotton candy worlds. Mostly because their overall density seems to be extremely similar to a typical cotton candy, usually less than 0.1 grams per centimeter cube, or 50 times less dense than planet Earth. As a matter of fact, because here density is technically much lower than even liquid water, in theory, if you were to have some kind of a massive pool of water where this planet can fit in, it would basically float on the surface. But that's obviously just a hypothetical scenario, just to help you visualize how extremely low in density these planets are. And so far, pretty much most of them seem to have relatively similar properties. Usually, they're much cooler and less massive than the other commonly found planets referred to as hot Jupiters, which are also known for being slightly inflated, but are still much hotter than Neptune, despite the fact that they're usually somewhat similar in mass. But size-wise, they're much bigger than Jupiter, because they're essentially like these expanded gas clouds, with the planetary atmosphere expanding thousands of kilometers above the typical range for a Neptune-like planet. And while surprisingly, these planets seem to be relatively common. As a matter of fact, at least one star system, Kepler-51, seemed to contain 3 such planets, relatively close to one another. But before we talk about more of their unusual properties, and before we discuss some of the potential explanations, we actually now have another new record. As reported in this study that was just published in June of 2026, here data from NASA's TESS mission, along with the ground observations from Antarctica, confirmed the existence of 2 more planets from the system TOI 791, which are now considered to be the poofiest of them all, the least dense planets ever discovered anywhere in the galaxy. So here we have 2 Jupiter-sized planets, with one of the planets actually even being larger than Jupiter, but that seem to contain just a tiny fraction of Jupiter's mass, thus giving them extremely low density. And specifically, planet B, the one that's about the same size as Jupiter, only has about 3% of its mass, and its sibling is even larger, with approximately 5.9% of Jupiter's mass, with the official densities now being 0.038 grams per centimeter cube and 0.047. But to understand how they formed and why they seem to be this way, we basically first have to take a look at how we think these planets form. So basically, let's discuss these signs of puffiness. And here we have to start with the solar system. In our system, we have a clear divide. Small rocky planets like Earth are usually near the Sun, whereas massive gas giants like Jupiter are much farther out. And based on what we know about planetary formation, planets like Jupiter first need to have some kind of a really massive solid core in order to create the foundation that can then start to attract more stuff like hydrogen and helium, eventually becoming as massive as they are. But these super puffs potentially lack this core, and instead seem to be giant balls of gas with very little stuff in the middle. Or at least that's one of the potential explanations for what's happening here. Although we do have some alternative explanations that basically suggest that maybe this is just some kind of a misobservation or some kind of a bias. For example, maybe this is just a result of a ring system, and what looks like some kind of a massive atmosphere instead is just a large ring system that resembles an atmosphere from a distance. Or alternatively, maybe these types of planets are continuously losing dust from the surface, or basically are constantly evaporating, creating a kind of an illusion of a massive atmosphere. This could be the case for some of the planets extremely close to the star, with other studies even suggesting that a lot of super-Earths we've discovered previously, and many different sub-Neptunes, might actually go through this puffy transition stage, when they're basically much younger and less developed, but as they age, they shrink over time. But in this particular case, this is actually still a bit of an extreme example, because here, apart from extremely low densities, these two planets also have relatively long orbital periods. As in, they're not actually orbiting that close to the star, and so here some kind of an evaporation might not make much sense. With this study even suggesting that what we're seeing here is actually the result of a missing step in a typical evolutionary process of a Neptune-like world. Specifically, today we believe that a lot of these planets very likely accumulate their gas much farther from the star. Mostly because once they grow massive enough, their gravitational pull becomes very strong and they rapidly attract a lot of gas from the surrounding gas-rich disk. But because these planets contain extremely low density, it actually implies that somehow these types of planets manage to maintain their massive gaseous envelopes much longer than they should have. Because normally, around most planets, we actually expect a lot of this gas to dissipate, usually because of the activity from the sun and mostly because of stellar winds. And so here the hypothesis is that somehow the conditions where these planets formed allow them to accumulate massive atmospheres without the star stripping them away. And even though the prediction suggests that these fluffy atmospheres should be lost over time, there seem to be some factors at play here that we obviously still don't understand that prevent these planets from losing their initial envelope. In other words, the suggestion is that quite a few planets very likely start this way, but eventually transform into something else over time. These planets, though, seem to stay in their baby stage much longer than expected, with one potential explanation suggesting that they very likely just migrated from somewhere much farther away and are now in this new location where maybe, with time, they will transform into something else after all. But basically, understanding the actual transfer and the timing of this migration right now is the main question astronomers are trying to answer. With one of the biggest questions being, so how long do they stay this way, and can they possibly stay this way forever? And while intriguingly, in 2026, a study of a young system referred to as V1298 Tau suggested that they most likely do not. This system is only 20 million years old, obviously much younger than the solar system that's 4.5 billion years old, with 4 planets in this system being extremely puffy for their mass. And astronomers now believe that these are actually missing links, because this potentially shows us that many planets are born a little bit bloated, but eventually shrink as they cool down and lose their atmospheres to various types of stellar activity. Although this particular hypothesis does not apply to Kepler-51 as well, because we know that this system is at least 500 million years old. But it might apply to a few of these planets because this process is already happening around a system referred to as WASP-107b. Here, this superpuff, about the same size as Jupiter, but only 12% of its mass, has been spotted with massive plumes of helium gas evaporating from the surface, and actually stretching approximately 5 times its own radius, which obviously suggests that this planet is leaking its atmosphere and will transform over time. Although intriguingly, for quite a few of these planets, despite their relatively large and expanded atmospheres, it's been surprisingly difficult to figure out what the atmosphere is made out of. For example, going back to Kepler-51, here when the starlight passes through the planet's atmosphere, it usually gives us a specific spectroscopic fingerprint, allowing astronomers to find out what's inside. But as of today, Kepler-51 planets gave us nothing, which seems to be the result of an extremely thick haze that expands from the surface for at least 6,000 to 7,000 kilometers, or basically the radius of planet Earth. But on top of this, this haze seems to be extremely similar to what we see on Saturn's Titan, which actually prevents us from seeing the surface of Titan, but just much more extreme, much thicker, and even more difficult to see through. Which essentially confirms that what we're seeing here as the planetary surface seems to be just the top of the haze layer, making this planet appear much bigger than it actually is. In other words, there are still a lot of mysteries about them, and we still don't really understand exactly how they form and what they seem to represent. We just know that for most of them, the real explanation is that these are indeed extremely large, expanded planets with massive amounts of haze on the surface, with this newly discovered system extremely unlikely to be anything else. In other words, in TOI 791, rings are unlikely to explain this because both planets would have to have very similar ring systems at extremely similar angles, which is statistically almost impossible. And that means that wherever this is, they do seem to be planets with extremely low density, but whose actual properties, composition, or structure we know practically nothing about. And that's because in the solar system, none of the planets seem to resemble them at all. We have no idea what color they possess, we don't know what they're made out of, and we don't even know their temperature. We just know that these are planets that take approximately 139 and 230 days to orbit the star, and they also seem to have a relatively permanent orbital resonance, which allowed scientists to calculate their mass, but also confirms that they possibly existed in these orbits for quite some time. And that's really one of the biggest reasons scientists are so excited to study these types of planets. They essentially challenge everything we know about planetary formation and planetary architecture. And that's because before we found these, astronomers actually believed that we understand planetary formation pretty well. But these oddballs definitively prove that there seem to be multiple ways to create a planetary system, and many planetary systems seem to resemble nothing like we expected. And so by conducting additional observations and additional studies of their atmosphere, planetary spin, and migration history, they'll probably provide us with a lot of insights on how giant planets form and how some planetary systems evolve over time. But right now, this discovery once again reminds us that the universe is much more mysterious and much more diverse than we ever thought. Once there are some additional discoveries, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.